The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
This week we're getting back to the mini pinball builds.
That's correct. Felix has wired up a test board so we can flip the machine. We're using the Teensy 3.6 microcontroller to drive everything, and we're going to be working with the Arduino IDE, so it's easy for people building this as a kit to make their own code. So in today's episode, we're going to start making the code like a state machine, like what the game is doing, making the main loops, making sure the audio can play, trying to pick a screen, things of that nature.
Sounds like a plan.
Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, Felix set up some test libraries for the pinball. He has a whole lot of H files here, probably too many. So when you call an H file, you can put C code in it because all it does is it just includes the file. So if you say, hey, include pinball libraries H, that means the compiler takes everything from pinball libraries and sticks it there. So it would be literally this. That's what the compiler does. But I mean, I do like how it kind of hides all the code from the user, which is kind of good. I think we should have like minimal things that the person can do. Putting C code in H files isn't really the accepted way to do it. It will function. However, the thing we have to think about with Arduino is if we do have external functions, we have to use them as a class. We can't just have external C because Arduino uses C++, not C. Yeah, so I guess I kind of have to think about what to do. So he's got a loop here, check buttons. So see, like I don't really know where check buttons is. I think it's under digital. Let's see, there's only one thing there. So this function may as well just be someplace else. Now here he has pinball functions, but in this header file, he just has the declarations. So this is actually acting more like a header file should be. See how it's basically the prototypes of the functions. Well, I made a copy of a copy just so we have backups. What I think I'm gonna do is start consolidating this. So, I mean, I might just, have this file be like he has it, because it's not the proper way to do it, but it works. And that way, the only file that the user would change is this INO file, which we realized means Arduino. See, if you cover up all the letters except for the end, it's INO. I never put 2 and 2 together. Although it took me about 39 years to realize what BB stood for. What can I say? All right, so what I'm gonna do is I'm going to try to compress some of these down and make it a little bit more straightforward. Because think about it, like if you're someone using this and you see all these files, it's kind of intimidating. I'd like to get these down to maybe 4 H files. Well, if we make proper header and C++ files, then we have to use classes if we're using the Arduino compiler. I don't know if that's just unnecessarily complicated, because what would happen is instead of having something just like saying play SFX, blah, 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 instead of doing that, you would have to have the function pointer. It would be like pin play SFX, blah, 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 blah. So I just have to figure out what's best. Up here, I have define name line 1, define name line 2. And this would be what the name of the person's pinball machine is called. It's a 16 by 2 character display, so I put 16 of these hash marks here above it to help the person, lay out how the spacing should be. So those would be the defines there. So I want to keep all of the game-specific defines in this top file. So these subfolders or subfiles, the user should never have to use. All right, so just really simply, we're just going to cycle between that and then a fake high score. So I'm going to save this. Oh, in case you didn't know this, if you are using the Arduino, if you go into preferences and say use external editor checkmark, you can use an external editor such as Notepad++, and it's much better. Then all you have to do is use the Arduino to upload. For some reason, I'm having to do this one manual every time. That's weird. So this would be what we'd call the machine's attract mode. When you turn it on and it's just sitting there waiting for you to start a game. So what I'm doing here is I'm just getting a rough setup of how that would work. And what I'm going to do next is actually put a state machine into the loop so I can properly access it. Okay, Super Custom Pinball Game X, top score. Cool. Now see how there's commas here on the score? It's because I manually put them in. If we were to not do that, if we just said int x equals 900,200,300 and then printed x, as far as I know, it's just going to print out the number with no commas. So we may actually need to create our own custom function to print out nicely formatted text with commas. The way a computer thinks of a number, it's all in binary. It's not, numerals on the screen. So you have to actually do some divide with remainder on things like this. So you have to sit there and you have to take the number and divide it like 10 times in order to get each digit and then put that on the screen. So what we would do is we would look at the length of the number and then we would put a comma in every 3 divisions, which would give us the proper 1,000s divider with the commas. But before I do that, I think what I want to do is put this into its own function to basically hide it from the user. So we define it here, but how the attract mode works will be kind of hidden. Because going through the top scores and all that, the user doesn't need to understand all that. We want to hide as much of that as possible. So that's what I'm going to do next. Next, I'm going to do type def, enumeration, then the types, attract mode, ball loaded, game active, ball drained, game over. All right, so we're going to create a type and it's going to be called possible states. Okay, then down here we'll have possible states and then game state equals attract. All right, so we defined a type here. The best way to explain that, let's say you said integer c equals 0, right? So the type is integer, the variable is c, and it equals 0. So what we've done here is we've made this as a type, possible states. But then we can't just say possible states equals somethings because possible states is a type. So we have to say possible states game state. So now we've made the variable game state into type possible states. And then we can say equals attract. So attract should enumerate as 0. So let's do this. Let's actually just print game state here just so we can see it working. Again, I should hide this someplace, but I'm just leaving it here for now. All right, Super Custom Pinball Game X, and then we see 0. All right, so if we were to type game over, man, it would be 0, 1, 2, 3, 4. Reprogramming, there we go. All right, the reason I did that was so that we can create a state machine in loop. So we do switch. We're gonna switch on game state, not game over. So this acts like a big function. And then inside of it, we're gonna have case statements. Case, attract, no matter what, the game will be in one of these states. But see, that's a nice thing about Notepad++. It will automatically detect variables and type them in for you. See, like that? Pretty cool, huh? And it's free! Dolby has clothes! I just know Max is gonna leave that in the episode. So let's do a test. Let's take this this top score thing. Now I'm not gonna remove the delays yet, but I will. Let's put that into the attract mode. Now again, I'll probably hide these in another file so that all the user would ever really see is, game active. We could even make it so this jumps to another file so the user doesn't even see this file. I guess that's, decisions Felix and I will have to make. Actually, let's not change the initial state of game state just so it doesn't work. Because a lot of times when you program something not working is just as important as it working. All right, so on the screen here, see how it's not getting past pinball test 03? That's because we have it's only going to game over and there's nothing there. So if we switch this to attract, it will do what it was doing before. So I'm gonna send it again and then that should restore the functionality. Okay, so now we've restored this, so that's cool. So what I'm going to do next is I'm just going to define a variable. I'm going to call it int LCD timer. And let's see, this is a 32-bit processor. Okay, so we shouldn't have a problem. The default ints and chars, well actually chars are always the same, but ints can be different. Int is for integer. If you're on an 8-bit micro, int is usually defaulted as a 16-bit signed value, which means it would be roughly negative 32,000 to positive 32,000. But then if you're on a 32-bit system, an int is going to be larger than that. So yeah, it's just always important to know what that is. Like if you wanted to be absolutely sure, you could call it an unsigned short, and then it would be a 16-bit number from 0 to 65535. Well, actually, if we want to be really safe, we can type unsigned long. Of course, if you were long is going to be 4 bytes, which would be 32 bits. That'll be from 0 to 4.2 billion. All right, so let's do this. So that's been reset. Let's have another one called attract state. I'm just going to use 0 and 1 for this. So inside of that case statement, we can make another case statement. but it'd really make our lives complex. Okay, so let's say in case 0, it always shows this stuff. Okay, then in case, I'm gonna make this 2, and I'll tell you why in a second. In case 2, it always shows you this stuff. In case 4, it resets it to 0. Okay, so you might be wondering, why did I skip case 1 and 3? Well, here's why. Oh, I forgot the break statement. I'm a terrible person. If you forget the break statement, it will fall through to the next function, and you don't want that. All right, so we're gonna do switch attract state, and then we're gonna print this stuff to the screen. So the reason I separated this out is because I just don't wanna print that stuff over and over and over because it's a waste of time. So we're gonna print that stuff to the screen and then do LCD timer equals 0. We'll reset it there. Now in case 1, what we'll do is LCD timer, basically we'll increment it. And then we'll do if LCD timer exceeds, I don't know, 50,000, then we jump attract state equals 2. So we jump to the next state. And we can actually make this a little bit more compact. We can just take LCD timer, increment, remove that there. Just makes it a little bit more efficient. Okay, so then right here, once we get to this, we draw it, and then we reset the timer again. And then in the next case statement, we basically do the same thing we did there, which would be 3. Well, I guess in this case, we could just reset it to 0. We don't need this last case state. Oh, and we also have to advance the state. So we need to do attract state. Now we could just do plus equals 1, but I'd rather just set it manually so we know exactly what we're gonna jump to. So really, in a way, we've made almost like a kind of a little program. See that? So we start here, we draw the screen once, and then we jump to this, and then we wait a bunch of time, then we set to the next function, then we basically do it all again, and then we reset. That removes the need for these delay functions. And the reason it's good to remove those delay functions is because we have some code down here, which is like looking for the button. If you're showing the screen like screen, and doing delay 2000, it will only be able to look for the buttons or sense the buttons between those delays, which is basically impossible. But by turning the delays into a timer loop, we can basically look at the button states at any given time and not miss a thing, kind of like Aerosmith. All right, now to see if this works. Well, the timer is way too fast. So one challenge we're facing here is when you use a delay command in milliseconds or microseconds, you know exactly how much time is going on. In this situation, we remove the delays altogether so the loop is running as fast as possible. And we don't know exactly how fast the loop is running. That's called pulled mode. That's why I just had to pull this number of, well, this is like 5 million. I just pulled it out of my butt. I'm like, oh, how many machine cycles? Well, not machine cycles. How many loop cycles should occur before we advance to the next state? All right, so then now it's running pretty well, but that's basically because we shotgun the value. Something else we could do, since this loop is like locked. Again, this isn't exactly what I want to do, but delay microseconds. Okay, so that would be 100 microseconds. So if we put in a fixed delay of 100 microseconds, that would give us a granularity of 10,000 hertz. So then we could lock this down. Then we could say, okay, if this is more than 10,000, 1, 2, 3, loop cycles, then we know 1 second has passed. Now there might be some stuff we want to run faster than 10,000 hertz, such as interrupt to check the solenoids. However, 10,000 hertz should be more than fast enough to detect any button press. Again, we can tweak this, but I'm just showing you kind of some of the theories behind how to do this. So let's see if this worked. 1, 1,000, 2, 1,000, 3, 1,000, 4. Okay, there we go. What I'm going to do next is add a few things to the attract state, then bury it so the user doesn't see it, and then work on the next state of the game. I did a few more things to the attract mode state machine. Instead of having the timer set directly, I created a function called display milliseconds. And instead of counting up the timer, I count down the timer. That way we can just put a number into it and know what it means. So we draw, the name of the game, and then we say display milliseconds 2000, which is 2 seconds. And the function, all we do is we take LCD timer equals that number times 10. And then we count down, and once it hits 0, then we change the state. So here with the scores, we display them for 1.5 seconds, jump to state 3. State 3 decrements the timers. Once it reaches 0, we increment to the next name. Once we get past all 3 names, then we increment back to attract state 0. So really, a state machine using a switch case statement can almost act like a little program within a program, and you can jump around and branch out within it. Yeah, so that should work out pretty well. All right, so that is a state machine that shows the attract mode stuff. What I'm going to do next is put in some button presses to play some music, and then I can show you the difference between having an inline counter and a delay counter. I've added a few more buttons here. We have button 6 playing a sound effect, ZAA, And then 1 is going to be the randomizer. I'll explain that later. 255 is priority. We also have a button which will stop the music. All right, so here's my function. Play sound effect. First of all, if the music is already playing, we're going to check the priority of what's already playing. And if the new sound isn't equal or higher to what's already playing, we won't play it. However, if it is equal or higher, then we will stop what's playing, wait for it to finish, and then continue on. So we try to load the file here. If we get back a 0, that means it couldn't find the file, and we return an error. Else, we start it up, and then we wait for it to completely start before we bounce out of the function. The reason we do that is because if the music file hasn't completely started yet, we can't assume that it starts. And if we try to play another one before the first one starts, we can cause like an I/O error. All right, let's program it over. Now you notice the LCD screen is still going to be updating, so all these things are happening at the same time. All right, let's try it out. There's the funky beats. LCD is still running. We should be able to stop it. It's kind of a buzz going. That's not cool. Oh, we'll figure that out later. Okay, we can resume it. That's good. Okay, so remember when I put in the timing in the display? So I'm going to show you why I did that. Okay, let's say instead of doing display MS, we did delay 2000. What would happen? Let's find out. Stop. It sounds like it's stopping it on the last sample. That's why we're hearing a buzz. Re-upload. Uploading. Do not turn the power off. All right. Let's run it again. Wait, the button's not doing anything. That's because we were delaying instead of using a timer. So by using a timer in our loop, we could make sure the buttons are being sampled as much as possible. We are delaying it to 100 microseconds per loop, but still, that's like 10,000 hertz. I think you can see a button press within 10,000 hertz. That should be enough granularity. We could always reduce that again. All right, well, I'm gonna check into why there's a buzz when I stop the music, and then after that, I'm gonna work on getting 2 channels to play at once. This code sets up the audio. So I created 2 of these objects because we want 2 channels. Audio output is what is going to the DAC, and then we have patch cords where we're connecting the left and right channels of our single audio source into the output. Now, Teensy has a pretty handy tool, which is this. I used this before, and I'm gonna use it again. Okay, so we have a wave thing here. So we want 2 of these. See how they have stereo outputs? Then we're gonna need a mixer. Actually, we're gonna need 2 mixers for left and right, and then an output. I guess that'll work. Okay, so we're gonna take the left channel here, and then the output of that goes left channel here. And then the right channel, we're gonna use the other mixer for that. So we're mixing the left and right channels together and then putting those outputs into the DAC. What this GUI will do is create code that we can put into our program. We go to export. All right, let's take a look at that. See how close we got. So this is the original code, and here's the new code. All right, so see how there's 2 objects here? Now we only need 1, so I'm just gonna do this. I'm gonna take this, see I'm using it with an array so we can index it easily. Get rid of that. Oh, let's comment out the original. I'm just gonna use what Felix was using because we know that works. So we're gonna leave the mixers, have the output there, get rid of that one. Okay, so here is where the magic happens. I'm gonna take this. Okay, well that's indexed. This is actually going to be 0, 0, and then the other ones will be 1, 1. So there's going to be play wave 0, play wave 1 are the 2 objects. That should allow us to open 2 files at the same time. Then we're going to put them into the mixer, and then we're going to put the mixer into the DAC, but the DAC isn't called DAC, it's actually called audio output in this case. Okay, I'm going to make another function here called play music, but instead of using play wave 0, it's going to use play wave 1, and it's also not going to care about priority. Ha 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 ha, get rid of all that stuff. Playing music. If play wave 1 equals play sound effect file name 1, well, that's just plain. Oh wait, we should actually have something here where we don't care about the priority, but if a sound effect is already playing, then we won't try to overwrite it. Something playing, we'll stop it and wait for it to stop. So we'll request for it to stop, I guess is a better way to put it. Request it to stop and then wait until it has stopped. All right, so up here with all our buttons, let's do this. So we'll have button 8 turn off the sound effects, and button 9 will turn off the music. Could have called one play sound effect, play music. We could have named the functions that, but I don't know. I just like having indexes because if you want to like go through everything and check, you can just have a for loop that increments the index number. That's one way you can do it. So I have a few sound effects in here that we can test. So let's go back to just plain sound effects. So we've got SA1. Now I'm going to make SA3 have a really low priority just so we can test if the priority is working. We have to make sure we have our priority straight. Okay, let's test this. Okay, let's do a test. Try some sound effects. The third one is only priority 100. So it'll play against itself, but if a higher priority sound is going, see how it can't interrupt until that sound is over? But the other sound can interrupt it. Wow, 2 channels at once. Well, that's all the time we have for today, but we made some pretty good progress with those libraries.
Yeah, you struggled with those a little bit, didn't you?
Yeah, the problem I came across was that Arduino expects C++ style libraries, and we were doing them in C style.
Oh, yeah, that wouldn't work real easy, would it?
We figured out a way around it. My goal is to have one file that contains all of the custom code for the person's game. All the other files, they should never have to touch.
If you have any comments or questions about the pinball build, remember to post that on the pinball subspace on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you later. Sure plays mean pinball, dude.